Hi everyone. Today I'm going to be talking to you all about independent variables. Independent variables are variables in a study that are manipulated or controlled. So manipulated variables are something that's assigned to a participant that the researcher can manipulate. For example, CBT in treatment group A or DBT in treatment group B. It's the approaches within these groups that are the manipulated variables. We also have status variables. So status variables are something that cannot be manipulated because they are already pre-assigned to the participant. These are things that the participant possesses. For example, gender or ethnicity. So although the participant possesses these and these cannot be changed or manipulated, they can be controlled for if the researcher sees that to be something that they would like to do and control for. It is imperative to operationalize the independent variable. So to do this, there are 4 different steps. Determining the conditions of the independent variable, reflecting the constructs that are designated as the cause in the research question, limiting the differences between conditions, and establishing the salience of differences in conditions. So let's go into a little bit more detail about these so we can have a little bit more of a thorough understanding. First, we must determine the conditions. So conditions are just the groups that make up the independent variables. These are determined by the researcher and referred to as experimental manipulation. As an example of a study with 2 conditions could be treatment group A and treatment group B, both utilizing different approaches. Or if we have 3 conditions, we could have 3 treatment groups that are utilizing different approaches, or we could have 2 that are utilizing an approach and 1 that's a non-treatment group. So second, we must reflect the constructs of interest. Within this, we must adequately and thoroughly define the independent variable. So for example, if your study is for individuals that have been diagnosed with depression, you would have one group that would be utilizing cognitive behavioral therapy and one group that would be the non-treatment group. So you want to be sure to define CBT adequately. What CBT approaches is the counselor using? Are they using discussions, activities, worksheets, homework? How exactly is CBT being utilized? And equally as important as defining the CBT approach is defining the non-treatment group. Is this indeed a group that is receiving no treatment, both CBT and medication, or is this group just not receiving CBT but taking their medication for depression? You must be sure to adequately define these, define them to the best of your ability so there's no room for error. An error with this could be that a participant in the non-treatment group just thought that she wasn't receiving CBT, but she could be taking her medication. Whereas outlined in our study, we put that there was no treatment, CBT treatment, and there was no medication used either. So this could create an issue when you start analyzing your results. Third, you want to limit differences between conditions. So these conditions should only differ along the dimension of interest to prevent from having potential confounds come up. To help with this, it would be ideal to consider and explore potential confounds before starting your research study. So if you recognize potential confounds, you'll want to add features to control for or eliminate these. For example, if you have 2 treatment groups, one utilizing EFT and one utilizing CBT, and they both have different counselors administering these treatments, a potential confound could be the counselor. So to control for this, to eliminate this confound, you could use the same counselor for both groups. But before doing this, you must be sure that this counselor is competent and experienced equally in both of these treatments. You wouldn't want this counselor being very competent in EFT but hasn't had much experience with CBT, because this could create additional issues. So before deciding how to control for these confounds, you want to think about it and be sure that the approach you're using to control for these or to minimize or eliminate these is effective. So fourth, you must establish the salience of differences in conditions. The difference between conditions should be somewhat noticeable to your participants but should not be transparent. So you want your participants to be aware of the condition, aware of what's going on in your study, but not to the point where they're able to infer your research hypothesis. because if your salience is too great, the hypothesis could potentially be inferred, which could create biased results, biased responses, and skewed results. And you don't want that. So you want them to kind of know what's going on, but not to the point where they know exactly what you are trying to get from this research study. And it's also important to perform manipulation checks. So there are 3 goals for this. First, to be sure that the conditions vary on the intended dimensions. Second, be sure that the conditions do not vary on other dimensions. And then third, you must be sure the conditions are implemented in the intended fashion. So let's switch gears a little bit. When interpreting the results of your research study, you'll come up with either statistically significant or statistically insignificant results. When your conditions are sufficiently different and display a true difference, you will come up with what you wanted, the statistically significant results. This will yield a p-value that's less than 0.05. So when this occurs, you will accept your hypothesis and you will reject the null hypothesis. So when you have statistically significant results, it is important to be sure that you don't have any confounds, and then you should also be on the lookout for type 1 and type 2 errors. So although we do want statistically significant results, we want to be sure nothing's going on in there that should not be. And then when your conditions are not sufficiently different and don't display a true difference, your results will be deemed statistically insignificant. So you will yield a p-value that is greater than 0.05. And when this occurs, you reject your hypothesis and you'll accept the null hypothesis. So when you have statistically insignificant results, it could be due to several things, such as no true effect, inadequate statistical power, which is just not enough participants, insensitive instruments, careless procedures, bias, or poorly designed independent variables. So when you get statistically insignificant results, you want to see what went wrong, what happened, what could be changed to better this study in the future so you yield significant results. So now I'm going to turn it over to Michelle so she can teach you a little bit about dependent variables.
I'm going to be going over the dependent variable with you guys from Chapter 19 out of the Heppner text, 2016, Research Design and Counseling. So just in talking a little bit about the dependent variable, the dependent variable serves as a measurable construct that is hypothetically the effect in an experimental outcome. So a few of these examples I'm going to go through with you guys will hopefully help you understand a little bit more about the dependent variable. So a dog owner would like to see if his dog eats more of a certain kibble. He feeds his dog blue kibble one day for dinner and red kibble the next day for dinner. The dependent variable is how much the dog ate of the kibble served at either meal. The independent variable are the red and blue kibbles themselves. How much the dog eats is dependent upon which kibble is served. Now there's room for error here, which we're going to talk a little bit more about in just a second. So when you have dependent variables, you can always run into reliability issues. So for example, the dog may eat more or less of the blue kibble for many reasons aside from the independent variables of the red and blue kibble themselves. Some of these reliability issues are known as types of error. Random response error can occur in multiple ways, such as respondent forgetting the agree or disagree scale when answering a question. So if you've ever taken a questionnaire, we know that sometimes there can be different numbers that would correlate to agree, disagree, very much disagree, or very much agree. And as you're going along through the questionnaire, sometimes you'll get caught up in the question and forget which response you're actually putting down. So this type of error can cause invalid results with the potential of the unawareness of the tester. The dog may simply forget he's a dog and mistaken himself for a human, right, that does not eat kibble. So this type of response would be a random response error. We have a specific error, which can occur when the respondent understands the question or answering scale. However, they desire to appeal to social norms. So for example, someone might be more or less depressed than they respond to a scale questionnaire, but they want to choose a socially desirable response, right? So the dog may not want to eat more of the blue kibble, but his best friend, the Yorkie, is right next to him, devouring the blue kibble, so he likes it very much. So thus he wants to appease his friend and eats more of the blue kibble. Another type of error that can happen is the transient error. Transient error is the effect of particular situation occurrence or mood state of the respondent when the experiment occurred. So for example, having a depressed respondent fill out a questionnaire immediately after their girlfriend broke up with them might cause an inflated or situational response. So for example, if the dog had been eating either the blue or red kibble but had thrown up on the carpet shortly prior to that, they might be less interested in either the blue kibble without it actually directly being related to the independent variable. So this type of error would be a transient error. Another type of error that can occur is scoring and recording errors. So this type of error can be when a tester or researcher accidentally or intentionally marks down incorrect data. So something could be like when you're using SPSS, if you accidentally put in the wrong data set that you were using, you'd come out with incorrect results, right? So inaccurate data. So back to our example, if the owner of a dog accidentally records that Fido ate 2 cups of the red kibble when he actually only ate 1, this would result in a recording error. Another type of error is compounding errors. So compounding errors is simply the accumulation of various errors we have discussed happening in the same research experiment. So at this point, you can have multiple types of errors that skew the reliability. So if multiple errors are occurring, you might actually need to just redo your experiment. So back to our example, the dog forgot he was a dog, refused to eat the kibble one day. The owner, however, accidentally recorded that he did eat kibble, and the dog's best friend also happened to be refusing kibble that day since his girlfriend just got hit by the mailman, right? So we've got multiple errors going on in this situation, and this is probably going to call, or most definitely call, for the research design to be redone to kind of take out some of these errors. So let's review the reliability. The benchmark for reliability according to our text, which is the Heppner text, is 70%. So the preferable score would be above 70. However, this percentage is sufficient for reliability evaluation. As a reminder, if the reliability score is 0.70, this indicates that there is a 0.30, which is 30% allowance for error in the data collection. Therefore, a sufficient reliability score does not necessarily indicate perfect score or accurate reliability. So this means it's just what's needed to kind of pass it on through as reliable. Okay, let's quickly get into some validity. There are various types of validity. The most important type of validity for researchers, which is going to be us in this case, is construct validity. Construct validity is integral in ensuring our scores are actually measuring our construct and not something else. So this is pretty important to our research. Multiple measures of a construct. We can improve our construct validity through multiple measures. So having more than one dependent variable is perhaps the best way to start. Utilizing solely one dependent variable leaves the experiment open for common occurrence of errors. But this can be helped by having multiple dependent variables. Using different assessments can also be a positive addition to research by improving construct validity. However, method variance can inflate the relationship. So something to be on the lookout for. Reactivity. So the dependent variable is often familiar or sensitive to the participant, right? So our textbook offers the example of someone with testing anxiety completing a questionnaire about testing anxiety. So the questionnaire itself might actually stimulate taking a test, thus inciting further testing anxiety. So this would be known as reactivity. It's important to consider unobtrusive measures when collecting data, but realistically, this might not always be something that's easy to do, right? Because if you're collecting information about somebody with testing anxiety, you might also result in testing anxiety. Some of the types of ways that we collect data, which is also very important. So this is self-reports, ratings, observations, indexes, interviews, projections, and unobtrusive measures. So these are different methods of data collection we're going to talk about here in a second. So self-reports. Self-reporting requires the participant to keep a journal, a log, or complete some type of self-report inventory. So this type of data collection is most popular in counseling research because it's the easiest to collect. Thus, even though it being the most popular, this can often cause some distortions to be collected in your data as well. So remember the types of error that we discussed earlier. Ratings of other persons and events. So this is kind of similar to self-reporting. Ratings of other person or events requires a respondent to rate a participant or event that took place. So think about some of the course surveys you might have taken in college, just talking about your professor or your other students in a course that you took, right? These type of assessments can also be relatively easy to use in collecting data. Behavioral observation. So this one's kind of a tough one that's not often used in counseling research, but behavioral observations is the observation of an individual in a specific situation. The observer is typically an expert or trained in the observation of a particular behavior. So like we said, this is more difficult to collect in counseling research because this takes a lot of time as well as a trained observer to get this type of data. Physiological indexes can be a great way to narrow biological evaluations to a specific construct, such as heart rate or cortisol levels, for example. This type of data collection, again, is not often used in counseling research just because it's very expensive and time-consuming in nature. So this is more of a medical model type of data collection. Interviews can be a direct way of gathering information for participants and also allows for flexibility in data collection. This is a type of data collection that's going to be more so used in qualitative research. So you wouldn't see this in quantitative research. It's very time consuming and can sometimes be inefficient in collecting data, especially large amounts of it. Another type of data collection is projective techniques. Though rarely used in counseling research, projective techniques can offer insight into participants' personality through ambiguous images and structures. So this is something like, Rorschach images that you may have used at a practicum site doing assessments. But it's also a very time-consuming type of data collection. It usually requires an expert to do. We also have unobtrusive measures. So this is kind of like observing behaviors in a room that are taking place without actually being a part of whatever is happening in that room. So this eliminates a lot of the reactivity problems that we see in data collection. However, it's not really going to be used in a lot of counseling research. This data collection can also be potentially unethical, considering privacy issues, and very expensive to obtain. Alrighty, I hope you guys enjoyed a little bit about the dependent variable in Chapter 19, and best